So today I want to take what you learned last week and go a step further with it. So the first thing that we did last week in the week 5 assignment 1 is you looked at molecular formula and empirical formula. We defined both of those and we understand that empirical formula is the reduced form of the molecular formula. In the assignment, I had given you some molecular formulas and you gave me the empirical formula. In order to go from C6H12O6 mathematically to CH2O, you simply divided by 6 each one of the subscripts. In another example, to take B2H6 to its simplest formula BH3, you divided each of the subscripts by 2. If you wanted to go mathematically and look at the opposite direction, if you wanted to go from empirical formula to molecular formula, you would do the opposite, and that is you would multiply by 6 for the first one, and for BH3, you would take and multiply each subscript by 2. What we want to be able to do today is look at the empirical formula and be able to get to the molecular formula and give that information. The other thing that we worked on last week from week 5, assignment both 2 and 3, but this particular question is from assignment 2, we took and looked at percent composition of a sample and we came up with its empirical formula using the calculations in the chart. You all did this problem. It was number 3 on week 5, assignment 2. We looked at lactic acid and you determined the empirical formula. Here's the calculation for doing that. The empirical formula that you obtained was CH2O. That is not the actual molecular formula of lactic acid. That is the reduced form. So today I wanted you to think about there could be another step, and that next step is finding the molecular formula of lactic acid. If the molar mass of lactic acid is 90.08 grams per mole, what is the molecular formula? So think back to that chart from the first assignment. I have the molecular formula and the empirical formula. I know what the empirical formula is, and that is CH2O. But I do not know what the molecular formula is. So I need to figure out what small whole number do I multiply the empirical formula by in order to get to the molecular formula. So I need 2 pieces of information in order to do that. I need the molar mass of the molecular formula and I need the molar mass of the empirical formula, and I'm going to divide them. So I'm going to take the molar mass of the molecular formula and I'm going to divide it by the molar mass of the empirical formula. You have to be given the molar mass of the molecular formula in the question. So you will always have the numerator. And in this question, it's given to us right here, it is 90.08 grams per mole. You will not have the molar mass of the empirical formula, but you will know what the empirical formula is. So I can take CH2O, which has 1 carbon, 2 hydrogens, and 1 oxygen, and I can calculate my molar mass. 1 times 12.01 plus 2 times 1.01 plus 1 times 16. Each of these numbers, 12.01, 1.01, and 16.00, if you remember, is the atomic mass from the periodic table. So the molar mass that I obtain is 30.03 grams per mole, and I'm going to plug that in up here. Mathematically, this gives me 2.99. That is close enough to 3, and 3 becomes my small whole number that I'm going to multiply my empirical formula by. So CH2O, C1, 1 times 3 gives me 3 carbons. H2, 2 times 3 gives me 6 hydrogens, and 1 oxygen times 3 gives me 3 oxygens. So my empirical formula is CH2O, and my molecular formula for lactic acid is C3H6O3.